Presentation that I provided at the Groundwater Summit was part of this breakout track that was really focused on data, as you can tell from the title, data, and more data. And what I spent my time talking about was essentially the investments that districts primarily make in collecting water level data and getting value out of those data. So I'm going to start by just talking about, just hitting on a couple points here, the essential value of water level data. First of all, water level data are essential for improving the understanding of local shared groundwater resource. The shared part of this sort of rings out the regulated aspect of the rule of capture. So, we're really talking about having to consider the shared, that groundwater is a shared resource. So data and information are really critical to improving that understanding. Secondarily, stationarity is dead, and I'm sure most of you understand that, or have experience around the fact that stationarity and independence are the two fundamental principles around hydrologic events, the whole science of hydrology. And stationarity, of course, is the statistics around hydrologic events, and particularly recurrence interval of extreme events. But with climate change, particularly the last 15, 20 years, we're seeing that stationarity is, if not dead, it's certainly been compromised. And so the fact that we can't rely on the statistics of hydrology as much, the uncertainty around that is much higher. It's really elevated the importance of dense real-time data sets, the sort of things that we're talking about today. And thirdly, water level data come into play day to day, week to week for the districts because of the information that's necessary for, in this case, we say quantifying, justifying, and enforcing curtailment. This again is that regulation, that regulated rule of capture. So data and information are really necessary, increasingly so for that. So the basic terms, water level data, first of all, you need to have a known location. You're measuring a level, essentially a depth from a known datum. And if you have elevation of that known datum, then you can look at water levels as elevation above mean sea level. So those are essential. Time is another essential part to create these time series data of water level. And then metadata is also important. The means of collecting these data, conditions around that, and so forth. So that's the essence of the water level data that is so critical to the whole operations and real insight into the resource. What are the investments? How are districts investing in collecting these water level data? Of course, there's the cost of equipment, whether that's calibrated tapes or pressure transducers or acoustic equipment like Wellntel. And then there's equipment just in the collecting of data. Then there's the expertise. We invest a lot in the expertise of our staff, and that's not cheap. Field operations, this is actual getting around and doing the collecting of data and maintaining systems and networks. And then we also invest, there's a lot of investing in stakeholders. The districts have a real responsibility to support their stakeholders and respond to stakeholders. In this case, I'm showing a slide from Post Oak Savannah District and highlighting their groundwater well assistance program. So this is one of their ways of interacting with their stakeholders, the water, either the permittees or residential folks who have rights to water, and responding either ahead of time for risks to water supplies or in response to the influence or the effect of say, high capacity pumping. So that's a way to interact with the stakeholders. But there's actually a sort of a broader culture around the working with stakeholders. And this is something that does take a lot of investment from the districts, because as you see here, this is Barton Springs, Edwards Aquifer District. They are in stage 3 critical drought. And you want your stakeholders, your constituents, the people that live within this district, one, to understand the basis for this declaration, and then to respond in a way that is expected and helpful. So that's a culture that has to be built around these sorts of issues, droughts, floods, and so forth. And they are dependent on data. In this case, for Barton Springs, the data they depend on for making these declarations are both spring flow from Barton Springs and the elevation in a monitoring well. So each district has a science community, and this can be either ad hoc or very structured. And from my view, from our experience, we see that the science community the districts have are staff hydrogeologists, staff technicians, consultants, technology experts like Wellntel, academic partners. We have a number of districts that are working directly with universities like Baylor and UT Austin. And then as I went through this morning, I actually added one here, board directors. We found that actually in some districts, well, let's say board directors come in all flavors, but in some districts, we've had the experience where some board directors are very, very well informed and may even have degrees in water related science. So those board directors can be a part of that science community. So this science community, so the district and this science community that's, as I say, either had ad hoc or really structured, there's some motivations for what they're doing. One could be economic drivers, the longstanding agriculture businesses in that area of responsibility. Certainly community growth is a big factor right now along the I-35 corridor, the hill country, community growth. So districts want to keep this economic engine going, but they have to, water is a key for that. And so they have to make sure that that resource is available and protected at the same time. And that's one of the other motivations is resource stewardship and resilience. After all, districts, are groundwater conservation districts, so stewardship and resilience is part of that. Database justification for curtailment. Again, this is the regulated side of the rule of capture. Database justification for well spacing and other policies. Also, having the justification, having the basis, the information to make these decisions in a science-based way. And then managing towards DFCs. Of course, this is another motivation for the science that you do, that's the science community would have to deal with. And whether that's refining the GAMs in a local area to help this managing towards DFCs or other aspects, whether at the district level or the GMAs, this is also a motivating factor. So this motivation around the science that districts do works to define the data needs to meet district objectives, conduct well-defined and collaborative data collection, maintain well-integrated data information systems for analysis and visualization, support reporting by permittees. This is a sort of a growing thing that we're involved in, helping permittees interact with the groundwater conservation districts and engage stakeholders, as we talked about earlier. So the rest of the talk is going to sort of be looking at the outcomes of these investments in sort of a couple categories, one being just the data collection side. So we talk about data collection. The most value that can be brought is if all historic data, all continuous data going forward, and this means any sensor, any data set, any time series data set that can be uploaded or brought in via API, and any third-party data. All of this data working together is the most efficient, most valuable way to bring this information together. So we'll show a bit of that. Analysis and visualization. This is the value of the data collection, is that the analysis is more robust, the visualization is more clear and accurate, and this comes through integrating these data sets, being able to look at spatial and temporal analysis, so both 3 dimensions, 4 dimensions if you add time. And so those trends are critical to understanding the resource and how to respond to current hydrologic events, weather, climate. And then this impactful visualization, trying to bring forward the most important view of the data that means the most to the science community, to the board of directors, to the GMA, and so forth. So I'll actually be showing examples of these. They're sort of interlinked. So data collection and visualization analysis, we'll look at those kind of together. And then the third sort of category here is engagement and reporting. So again, engagement with stakeholders, building that culture requires this engagement with good solid data and good interpretations. So on the engagement and reporting side, we've got both resource and operational alerting around data, compliance reporting by permittees, we touched on that already, and engagement with the public and other stakeholders. So let's sort of dive into some examples of this, starting with the data collection and analysis visualization sort of together. And my first example for you folks in Texas is actually going to be in New Mexico. So I hope my cursor is showing up. So this is in the southeast corner of New Mexico, and these 10 wells are historical wells, monitoring points for an area with real intense irrigation. This is the Pecos Valley Artesian Conservancy District. And these, we're going to look at the hydrograph from one, Artesia A, which is located right here. And it goes, this record goes way back into the 40s. And this is a record of hand measurements that were collected more than once a month over all of these years, looking at, highs and lows, a lot of irrigation effect here. But this is how it was done in the past. Really solid data, beautiful trends. But what's been added here lately is continuous levels using pressure transducers. So no longer trips to the field, every week and a half, 2 weeks. Now this is remote data coming in, pressure transducers, and you can see the density of the data. So we're going to zoom in here to this last bit of the record, and you'll see what this integrated data look like. And so here's the red is the hand measurements, the manual measurements, periodic readings, and then you've got the blue pressure transducer data that are added. I don't know if you can see it here, but there's been a continuation of the manual measurements even through the new continuous data, which is good practice. So this is an example of a full integrated data set that's essential for this long-term and short-term analysis and management. But the important thing is here how data sets can be brought together. I'll show you another example. This one happens to be in Texas. This is Post Oak Savannah District. And here's an example I should have mentioned on the previous slide. The yellow here are listed as the other sensors. And for the previous example, those were the hand measurements. So here at Post Oak, we've got both blue, which are Wellntel sensors, and yellow, which are other sensors. In this case, the other sensors are both manual measurements and pressure transducers. The point here is that this network is integrated. It's all managed together in one location. And we'll look at the city of Gauze just as another example of integrating historical data and more current data. So here's a hydrograph, water depth over time of the levels in this city of Gauze well. It's a municipal supply well. And you can see that over this period from the 50s, 60s, I guess, there's over almost 150 feet of drawdown, very visible in these sort of annual, roughly, measurements of tape down. And then you see this really dense data set that has come on recently, and this is a Wellntel instrument, and Wellntel sensors have been added. So we'll zoom in here, look at this recent data, and again, the periodic values here, and then it's very dense temporal, acoustic, real-time, continuous data collected by Wellntel. And here you'll see that this is collecting pumping data as well, looking at drawdowns. And the nice thing about these data is they're tagged in a way that we can filter out anything but the static, the non-pumping data. And now you see that very clear saturated thickness of this resource over time, and how much more detail you see with this continuous real-time data, and how it conforms with, as they've also continued to take tape downs as well. But this additional data gives you a real insight into the seasonal changes. And in fact, you can see here that subsequent highs, seasonal highs, and subsequent seasonal lows are both on that downward trajectory. This is an example a little bit different. This happens to be Bell County, so this is Clearwater District. In this case, it's not depth that we're showing, but elevation. So, and the important point here is that you want to be able to look at more than one well together. And so we've got 5 different wells here plotted together, elevation over time. And the real insight coming from this is that with elevation, you see that 3 of the 5 wells have a fairly similar elevation over time. And they are these 3 wells out to the west. And then 2 wells have a much lower elevation here off to the southeast. And this is really wonderful insight that sort of suggests and then sort of confirms that there's a hydrogeologic change that's happening between those sets of wells. In this case, in southwestern Bell County, they're chasing understanding of a fracture system that is offsetting and affecting the groundwater system. Also wanted to make the point that public data can provide a very important context around data that are being collected by a district or by a company, by a water supply corporation. And what we have here is showing how public data can be brought into a session for analysis and integration into the data that are being observed. So this is a system we have out with the Bureau of Economic Geology out in Valverde County. Our sensor is the blue sensor right here, or blue circle here. And to search for public data, we drop a pin, a location. So we drop it right on that well. And then we can search around that pin for public data. So in this case, we set a query distance, a query period. So we selected 10 years around that point, 5 years. We want to look out 5 years for data. And in this case, you see we've got USGS well, USGS stream flow, and state APIs, NOAA precipitation, state APIs. These are data sets from the state that can be brought in. We're doing this for a number of states. We're still sort of talking with Water Development Board about how we can make this work in Texas. But in this case, I'm going to choose USGS flow, so stream flow. So I'm looking for stream flow data within this distance of the Wellntel site. And via API, the system goes out and asks USGS what flow are available to meet those criteria. USGS responds saying we've got one flow sensor in the area to meet those within that 10-mile radius. And then we can upload those data for the session. And that's the purple location here. So we've got our Wellntel sensor and we've got USGS stream flow. And then the analytics and the analysis that's possible on this platform is that you can bring those two together and look at them together. And in this case, we want to explore the relation between shallow groundwater levels and surface water flow. In this case, the green is the water level in the well, Wellntel data, and then the orange is USGS data for flow. So I'm going to end here with a few slides or a little bit of discussion around the engagement and reporting side of this. And that it's the cloud-based analytics that really enable this ability to see quickly what's happening, either a static view or a view of change over time. And this really allows water managers to decide, okay, do I understand what's happening? Are things changing in a way that I need to react? Or do I need to go to a deeper analysis? Is this something I need to engage our consultant around, or are the data clear and sort of understandable as this first pass of visualizations? So in this case, we're showing a groundwater contour map around, in this case, changes of levels over time. So that's one indication of change. And another is looking at 3 wells in this case and normalizing their hydrograph to a point beginning at a particular time, and then seeing how they each have changed in relation to each other over time. So anything that can be visualized on the platform can be saved and shared, can be automated in certain ways. So there's a very powerful way to look at data to give the districts the tools to decide, are we understanding the process and the status currently? Do we need to engage the consultants? But it's a really powerful way to be looking at these data continually. Also, embeddable charts is a really useful way for districts to engage the public, or internally or externally for the public. And I'm going to show you a few examples of these, of embeddable charts. The first is Uvalde County Underground Water Conservation District. And on their public website, on the very front, you see a tab for groundwater levels. So this is publicly available. So you click on groundwater levels, and there's three Wellntel systems, 3 wells with Wellntel systems posted right now. You go look at Byler Ranch well. So this is what comes up that the public can access. Byler Ranch well, daily maximum elevation. So this is the daily highs. And they have requested that they have 3 views of these data. And so this first one is period of record. This goes back into 2020. The second view would be just the past 365 days. So that's this view to the right. So that stretches out to fill the graph. So that's 1 year of data. And then the other view is the current water year. So that begins October 1st. So this is what Uvalde County wants to be presenting to their public. And this is an interactive, I can't show it here, these are just slides, but this is an interactive way for the public to engage. You can run your cursor over and get actual values. You can zoom in. You can download plots. You can download the data. Another example is Central Texas Groundwater Conservation District. And I just point out here that the board imposes a 15% mandatory water reduction for 2023. That's that culture that you try to build over time, right? That you want people to see this and say, okay, we understand that's based in data and real understanding of the resource, and that the public is willing to go along with that because you've built that cultural around it. So in this case, groundwater data here, if we click that, it comes up with this monitor well network. And this takes you to this map where the colors represent different aquifers that this district is managing. This particular site, this well, this is a Ellenberger San Saba aquifer well, and clicking on that will take you to, again, to a Wellntel view of the data. This record goes back to 2021. Here, they just want one view. They just wanted period of record. So that's what's being shown here. And you notice here, it says last compiled on a date at a time. Every time someone comes to this embedded chart, it will compile the data to the most recent. So in this case, it will be, since it's a daily minimum, it's going to be the day before. So again, interactive, always updated and available to the public. So I'm going to end with this and welcome questions here. Just wanted to touch on, as I said before, there's the opportunity for assisting permittees with compliance reporting. And this can be either through standardized reports or customized reports that the permittee, this is on them to do in collaboration with the district. And we're doing this more and more for water supply corporations, for MUDs and SUDs. And it just makes their job easier, and they know that they're providing to the district the data in the format, standardized and automated in ways that makes it easier both for the water supply corporation or the permittee and the district. And it's water levels collected in both production and monitoring wells. And in this case, you see a table of data for July 2023. These happen to be 4-hour readings every 4 hours for levels, and then again a period of record plot and the July plot. And reporting can also include production flow data and cumulative acre feet accounting for many permittees that meeting that or staying under that permitted acre feet per year, per month, whatever is very, very critical. But hopefully that'll give you some ideas of how we envision data and information and working with districts and their stakeholders, and would welcome discussion around all of that.
I'd like to know, how can we get private well owners interested in volunteering their wells to participate in our monitoring networks? The well owners have challenges around sharing the data. I wanted to know how we had accomplished that, or how other districts have accomplished that.
So yes, many of our networks are overwhelmingly volunteer residential well owners that have joined forces with the district to provide data. So the first thing is that their data, any volunteer private well owner, their data are their data. That's the starting premise. And it's only by agreement that they're providing those data to the district. And they can request, to stay anonymous if that's their preference. Of course, location and other things, sometimes you can actually figure it out, but protecting privacy and security is paramount, and our system is very well designed to manage that. The other things that are that should be attractive to them is that we provide any private well owner that's part of a network, let's say for Post Oak, any of those volunteering well owners will get their own dashboard, not the analytics dashboard that the district or the sponsor uses, but a dashboard for just their well, where they can see what's happening in their well, things that they've never seen before around pumping activity, drawdowns, recovery, how much are they pumping, how frequently, how deep, how close is the drawdown getting to their pump. So, and they can set alerts around that, both the pumping duration and levels. So for many of the private well owners that are volunteering, they really appreciate having that insight into their well. So they're seeing things that they've never seen before in their well and operations. You can identify if the pump is running too long. Is there a leak that you have to track down? So it's both of those things. That their privacy is maintained by whatever agreement they have with the district, and they have the ability to see their own well. They can't see anybody else's, but they can see their own well in real detail that they've never seen before.